important. Okay. So there are some formulas which you should be knowing whenever a collision happens, and the formulas are that force force uh, force is equal to rate of change of momentum. Now this means change of momentum change of momentum divided by time. Okay. Now this can be written as force into time is equal to change of momentum. That force into time is the impulse. Okay, this is the impulse. Force into time is the impulse, not the force alone. You can call it impulsive force, but when he's asking you the impulse, he's not asking you the force. He's asking you the product of F into T. Okay. So now the point is, how do I write this? I write impulse is equal to force into time is equal to change in momentum mv minus mu, where v is the final velocity, u is the initial velocity. Okay. So now he's asking you what is the momentum you were, he was asking you about this. So you said m, which was of the dummy, the mass was 70 kg. So and the speed of the car was approaching at 20 meter per second. So the dummy was also approaching at 20 meters per second. So he's actually only asking you the momentum of the dummy, not of the whole thing. So that is mass into u, which is 70 into 20, which is 1400. This you were right, kg meter per second. Then he says calculate the impulse that may to bring it to rest. Now, if it is to come to rest, that means the final momentum mv must be zero. The final should be zero. So this must be zero. So 1400. So the same thing. 1400 should be the impulse, because impulse is mv minus mu, which is 0 minus 1400, which is effectively 1400. Okay. So this is the answer. 1400 is the momentum, and the same numerical value, he says, same numerical answer. Okay. Then he comes to the next part. He says in the crash test, the passenger compartment comes to rest. Now he's not talking of the dummy, he's talking of the whole passenger compartment, and he's talking of the whole thing, this whole thing. So this passenger compartment comes to rest in 0.2 seconds. He says what is the deceleration? He's not asking you, he's not given you the mass of the compartment, so we can't do anything with mass. And he says just the time is given. But then we know the velocity is again, what is deceleration? V minus u by t. V is 0. And initially the same velocity it had. This is given to be 0.20. So it is basically minus 20 by 0.20, which is 100. This can be written as 20 by 100. So this goes up, this cancels. So it's 100 meter per second square. 100 meter per second square. Okay, this here. Next, the the seat belt and the airbag bring the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80. So he's not taking 100 meter per second square. He's taking the average deceleration of the dummy, of the passenger, of the dummy as 80. Then he says calculate the average force applied to. Can you tell me how to do this? Hmm. 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 So Ah, very good, very good, very good. So it's 70 into 80. So about 5,600. Now he says the deceleration of the dummy is less than the deceleration of the part. Explain why this is, and can you tell me why the deceleration of the dummy is less than the passenger deceleration of the passenger? The deceleration of the passenger is 100. The deceleration of the dummy is 80. Can you tell me why this is less than that? First, tell me why it is less, and then tell me how does this help.